Hello everyone, myself Devc. Currently I am studying BTech in the stream of CSC Computer Science and Engineering at Srinivasa Ramanujan Institute of Technology. Today for my DEVC assignment, my topic presentation is presentation on the directional derivatives. Today I am going to discuss about the question: find the directional derivatives of xyz square plus xz at 1, 1, 1 in the direction of normal to the surface 3xy square plus y equal to z at 0, 1, 1. To find the directional derivative of the function f of xyz equals to xyz square plus xz at the point of 1, 1, 1 in the direction of normal to the surface defined by g of x, y, z equals to 3xy square plus y minus z at the point 0, 1, 1. To solve this question, we have to follow the several steps. Step 1, to calculate the gradient of the f. Gradient is nothing but del f. Del f equals to dou f by dou x, dou f by dou y, dou f by dou z. We have to partially differentiate the given function with respect to x, y. Then we get the following answers. Calculating the partial derivatives, dou f by dou x, we get xy yz square plus z. Partially with respect to y, we get xz square. Partially with z, we get 2xz plus x. Now we have to substitute the given point in the where we get the formula. We get the xyz values. Del of f of 1, 1, 1 equals to, by solving this equation we get 2, 1, 3. We have to substitute the given point into the given function. After finding the function, we have to calculate the gradient of g. Then this step is called second step. Second step follows the calculate the gradient of g. Next we calculate the gradient of g. Del g equals to dou g by dou x, dou g by dou y, dou g by dou z. We have to partially differentiate the g function with respect to x and y. We get the values by calculating partial derivatives. With respect to y, we get 3y square. With respect to y, we get 6xy plus 1. With respect to z, we get minus 1. After getting the values, we have to substitute the same as we did in the del f by substituting the given point 0, 1, in del g. Del g of 0, 1, 1 we get 3 into 1 square, 6 into 0 into 1 plus 1 minus of 1. By substituting these values in the del g formula, we get 3, 1, minus 1. At last step, we have to find the directional derivative calculation. To find the directional derivative of function in the direction of normal to the surface is given by the formula d into f equals to del f into del g by mod del g. We have to find the magnitude of del g. First we have to find the magnitude of del g. Del g we get 3, 1, minus 1. By to find the magnitude, we have to square and the multiply square and the find the root. That follows, we get 3 square 9, 1 square 1, minus 1 square 1. These all under square root. We get the del g magnitude equal to root 11. Now normalize del g. To normalize del g, we have to divide the given. We have to divide the root 11 with where we get del g by substituting 0, 1, 1. Then that is called as n cap. N cap equals to del g by magnitude of del g, that is equals to 3 by root 11, 1 by root 11, minus 1 by root 11. At last now calculate the dot product. Directional derivative of the function equals to del f of 1, 1, into n cap. That is equals to del f, where we get del f 1 comma 1 comma 1 value equals to 2 comma 1 comma 3. Now we got the n cap value. With these value we have to do the dot product between these 2 comma 1 comma 3 into dot product into 3 by root 11 into 1 by root 11 into minus 1 by root 11. By calculating with these two products, we get 1 by root 11 into 2 into 3 plus 1 into 1 plus 3 into minus 1, that is equals to 1 by root 11 into 6 plus 1 minus 3, that is equals to 4 by root 11. At last, final result. Thus the directional derivative of the function at 1 comma 1 in the direction of normal surface at 0 comma 1 we get 4 by root 11. Thanking you for watching. Abhishek Paul signing off. Thank you.